Hi everybody, this is Vanshika, and I'm going to, as Jimmy said, on retail product detection with FiftyOne and YOLO. A little about me before we dig into that is my name is Vanshika, if for people who can't pronounce it properly. And then I'm working as a data engineer intern at UNAR Labs, and I recently graduated from a master's in machine learning and computer vision from Northeastern University. And if you are interested in connecting with me on LinkedIn and check out my portfolio, I have dropped the links there. All right, so it's a Thursday, and you're already thinking about weekend, right? So at least I am doing that, and my weekends are usually like spent in grocery shopping. It's quite an adventure where you like spend half your time trying to remember if you need milk, or the other half debating whether you need to buy those organic apples. And then there's this self checkout machine where you basically scan, beep, and then you have to bag it and then just repeat the process for all the products. Now, every time like an item doesn't get scanned or accidentally get missed, then like you're losing a lot of money. So if just to give you some perspective, retailers in the US lose over $100 billion every year due to shoplifting and errors at checkout. So that's like a lot of money to buy all the fancy organic apples for life. So this is where I am introducing computer vision, which is using tools like FiftyOne and YOLO for object detection. We can ensure that everything is scanned and prevent those sneaky shopping shenanigans. All right, I have put the baseline, but for any model, we need dataset. So to train a system like this, you need the dataset that I've chosen is retail product checkout, which is RPC for short, and it's packed with 200 types of products, 17 mega categories of puffed food, drinks, milk, etc. But they also have an interesting level of clutter. So if you see the first top image, that is like a very few items in easy mode, and then it increases the level with a lot of items in the hard mode. Now these are some of the example images of 12 different categories. I couldn't fit all the categories in the slide, but I definitely recommend to check out the paper. They also mention how they collect this training data set with different viewpoints and different perspectives. I was about to tell you how to set up FiftyOne, but Harpreet did that very well. So it's basically you just have to create an environment first, and then okay, I just sent it. Yeah, create an environment first, and then just do pip install FiftyOne. And this is also a quick video, but I'm just gonna skip that. Now, let's see where FiftyOne really shines, right? Imagine you have to basically track every product in your data set and also the annotations. It's just very messy. But with FiftyOne, you can visualize, manage, and clean your data set effortlessly, everything in your notebook. But to do that, first we need to follow some rules, which is organizing your data into how FiftyOne can understand. For this, I created train, val, test dataset, for images as data, and for labels as a JSON file. And if you find this confusing, you can definitely check out FiftyOne tutorials, which is quite easy to follow. Now, let's see the exciting part where you can actually see the dataset in your notebook, which is just by launching the app inside the notebook. And if you have a label dataset, you can also see the predictions. In my case, I do have, so I can see the boxes, which is like in the blue color. And you also notice a tag, the unique tag, which is a tag that I created, and I'll discuss that later. Now I can quickly show you the notebook. I hope you can see the notebook.
We see the notebook.
Okay, great. So first thing is to download the dataset, which I have mentioned here in the link, which is 15 GB. So make sure you have that space. But also you can just Google RPC dataset and you can get it from there. And then a little tweaking is in the labels file. So this is basically how FiftyOne access the labels, and it is given by the tag called name. And as I mentioned before, it has 200 different products, but I did not want to use all the different 200 labels. So that's why they have something called super category, which is 17 labels. So it just makes my life simpler to visualize. And that's why I just tweak the JSON file a little bit to change the super category as a name so that 51 can recognize that. And then to create the data set, I created an alias for 51, which is FO, and then you just call dataset. In my case, I'm loading it from directory. You can also load it from a path. And then the the basic steps, the basic parameters I pass in is the directory path where my data set is loaded, and then the type. So interestingly, the data set that I have is already in the Cocoa format, which means I don't have to customize the format much. And then I can also give a name for the data set. So I am creating three different types of data set. One is for train, val, and test with three different names, which I define it here. So let me go back. So now talking about the metadata, I know it sounds boring, but it will be interesting once you start playing around with 51. So when I talk about the name, it's basically a unique identifier for your dataset, which either you can give yourself or it will be auto-generated based on the date and time. And then there is the media type, which is either image or video, whatever the type of data you're using. The number of samples, I have 53,739 number of images. And then coming to the main thing, which is persistent. So that is whether the dataset is saved permanently or it's just temporary in your notebook memory. And coming to the tags, it's like the keywords that I mentioned before, unique. That is one of a tag. But right now I don't have any tags, that's why it's empty. Uh, and then there are some sample fields associated with each and every image, like the file path and the annotation of ground truth. Also, one interesting thing to note here is you can um, organize and play with your dataset using pandas like functions. So, like how we do dataset.head to get our first 5 rows of the dataset. Similarly, you can do that here. And then get field schema is basically getting the columns of the dataset. Now coming to understanding our data and just inspecting how the dataset it actually is. Right? So in this GIF that you will see, it's basically identifying blurry images. And the way I do that is I can replay this. So if you just go to the operations it has, you can just search in blur and then it will give you, if you want to identify the blur images, all the images or just a view. So I'm just selecting few 500 samples to make it quickly. And then I can just tag these by adding a tag option right up there, which will pop up right now. Yes, and then you can just name it as blurred or anything you like. And when you apply, it will basically reflect on all these images in your app. And it's not just about identifying blurred images, there are other image quality metrics as well, like aspect ratio, brightness. You can check out the GitHub link that I mentioned here for other kind of tools. Now, I know that finding blurriness isn't a big deal, and like most of our data set today won't have that kind of blurriness. In this, also out of 500 samples, there are just 8 images that are blurred. Talking about the real stuff that our data set could have is like finding similarity or duplication of images, right? Because you don't want to train a model on the same kind of image. It's wasting the valuable time of training, and it can also lead to skewed results. So 51's brain feature helps us to identify and basically remove similar images if you want to. And this can reduce redundancy, of course, and improve efficiency. So the way I do that, I can just walk to the demo. Yes, so basically, again, go to the operations, and then you just have to duplicate. Here, you can, yeah, before we do that, we have to basically, yes. So we have to compute similarity, which is something it's present in a function present in the brain, which is 51 brain FOB alias. And that is going to find out on any data set that you want. And you can also give a name for that brain function, and then you can also choose your model. But this is something which is a very common model to use, which is VIT clip model. And metric is cosine similarity, and that is going to give you what are all the images that is similar in this kind of data set. If we go back, yeah. So if you want to see the GIF again, which is you can also save the threshold. So you can also set a threshold to find the similarity or the fraction. Here I select zero point 0.7 threshold. I want just very high similar images, and I get 8 again. And then I can just select and write any tag I want, duplicate, blur, and this is the blur and duplicate image. So it has both the tags. All right. You might be wondering that just tagging and visualizing images is a good thing, good to visualize, but how can I actually use them in my, if I want to perform any function, if I want to remove them or train another subset of data set? Well, you can do that because each session that you launch an app in your notebook, it will basically store all the sample IDs in that session, and then you can just select them and the dataset that you use. So in my case, I use val dataset. I just select those sample IDs and create a subset of that dataset, which is interesting. So here I have 133 subset of data, and then I can uh, play around with this. I can identify if there are some misclassification in this particular thing, right? So that is there. Now coming to the moment of truth, which is evaluating, right? So I did not train the model, this notebook particularly, because I had already fine-tuned the model on this data set and I uploaded that in Hugging Face. For the if you want the weights, I have linked the link here. And the model that I use is YOLOv8. Now, coming to the 51's evaluation API, it provides like very powerful tools to assess your model's performance. In particular, to this use case, which is object detection, which is the metrics that I use are precision, recall, and mean average precision, which is MAP score, right? So, just very quickly, I know everybody knows this, but precision is like how often your model is correct, and recall is the ability to detect all the relevant substances that are present in your ground truth. And map score is basically the overall accuracy, which is a very common metric used for object detection, right? I will give you one example of the predictions that I have. Yeah. So just read on this. So basically, these are all the predictions, and I select one of the image here, and then I'm just selecting the predictions for now, and then I can just choose the confidence level. And then I can also select the labels that I want to see in this. So chocolate, canned food, instant drink. I selected all these, and then yeah. So basically, if you want, okay, let me tell you this, and then I'll show you the notebook again. What it basically is doing is when I run an apply model on the data set, it's going to give me all these predictions of the on the data set that I applied the model on, ran the prediction on, and then you can just evaluate the detections based on this function, which is basically the ground truth field that you have in your label data. So in my case, it is called as detections. And then the prediction field is where the YOLO model is going to store the results. So in my case, it's called predictions. And then you can also give a key. So if you want to evaluate different types of prediction metrics, then you can set different evaluation keys. In my case, it's just one, so I just put eval, and the classes, of course, to run the evaluation on. Yeah, now coming to the notebook. So, yeah, this is the model that I'm using. Yeah, I shouldn't have printed that. Okay, so I'm just taking 5,000 images from my test data because it's 24,000 images and it's very huge to test it on. So I just want to see how it performs on a subset. So randomly, if you want to take something from a data set, you just do dataset.take and it will randomly pull out some images. And then on this particular data set, you just apply the model with label field, mention the label field name, and then that's just going to put those prediction on the data set, and then you can just launch the app on that particular data set, and that is the one I was showing you in the presentation. Right. Now coming to the evaluation part, noting down the precision, recall, and map score is great. Even looking at the confusion metrics is great, but you want to know where your model went wrong. So that is why we need to see what are the false positives, what are the false negatives, right? So before we do that, this is just a graph bar chart of top 10 classes, which is tissue, dessert, drink, and their precision scores. Not that important. Now let's go to the important part, which is finding out hard samples. As I said, finding out the incorrect detections and the misdetections is actually important. So when you evaluate, you will get these three metrics, which is eval TP, FP, and FN, and then the I can just select the range I want to see. So in this case, I'm selecting at least one true positive I need to see in the predictions, and false positives is the same, and false negatives is also at least one. And then if you see in this image, yeah, so I'm selecting the false positives, which are five in this case. The green ones is basically the ground truth, and the blue ones are the predictions. Yes. Okay. So taking one particular example in this case, it's not a GIF, I've just taken a screenshot. In this case, you see the green one is a ground truth, which is named as instant drink. But the prediction is basically candy. And this was also predicted as candy, but I I highlighted only the green one so that it's clear to explain. And in this case, you can clearly see that it's incorrect detection, right? And then when you see the gum, it's basically a misdirection because there's only one green and there is no blue. My point is you can take a closer look at your false negatives and false positives and then identify where your model is missing. And this kind of visualization of true label and predicted label side by side is very important and I guess easy to evaluate your model performance. Okay, so that's like some of my points, like seeing the predicted labels alongside the true labels. You can help pinpoint where the model exactly went wrong and where it's actually struggling, right? You can also analyze some of the patterns in your data set if the same mistake is being recurring. So then you can identify where or what kind of data set it is actually failing on. And then talking about the model performance, like if you understand these discrepancies in your data set, it can provide like a roadmap to for targeted improvements, like refining the training data set or adjusting the model performance so that you can actually get a very highly precise and robust model. Now, like if you ask what is the basically why you would use 51 is it can streamline the entire process, right? As you saw, data loading, curation, and model evaluation. So it can basically save you a lot of time and effort. And to get deeper insights into your model performance in the production in the predictions part, it's actually helped, and you can also gain where your model is performing well, like how I show the top 10 performing products. Now, what is next? I have just shown you like little some of the tools that 51 has for dataset curation, but definitely you can check out. There are other tools that you can use to make your dataset high quality, error free, and you can also try these on video datasets. That's what I'm going to do next on of Kitty dataset, and then you can also try different models. I just tried the YOLOv8 model, which is, I don't know what the version is running right now, but pretty sure it's a very old model. So you can definitely try the segmentation model to segment these products or on any other data set. And definitely check out the tutorials of 51, which is a very good start. And if you don't have any dataset in mind, you can just use the quick start dataset to try out. But I definitely would recommend to do hyperparameter tuning, which is what I haven't done in this case, and also data augmentation, if that helps. Yep. Now, I can quickly go to the notebook. Uh, yeah, this notebook is available to the public, so you can look out later if you're interested. But this is just the setting up of 51 and loading the data set, which I already explained. Now, yeah, this is just the histogram of product categories, which is I have 17 categories and the number of data points I have in the train set. And then this is the identifying the blurriness. And this is where I use the compute similarity function, which is again a VIT clip based model to find the duplicates. And then how you can just select these and tag these and use them later on to create a subset of data set. And the unique images, just like how similarity works, you can just find the uniqueness, which is compute uniqueness function. And then again, you can just tag them. And then this is about how to load the model, which is a push and hugging phase. And these are the metrics that I'm using. Yeah. And then this is how you would apply the model on any kind of data set. And this is basically explaining what the parameters are for the evaluation. So for evaluation, again, it is detection model, but you can definitely do a segmentation. So there are a lot of evaluation types or functions available. Yeah, and then you can also, I did not show this before, which is basically you can get the overall info of the results of this evaluation, and it will give you basically what is the method that they use, what is the prediction field. If you like, you just mentioned it here, but if you don't remember, then that's just what there is. Then you can also set the IOU threshold for the bounding box. For me, it's just zero point 0.5, and then these are the thresholds that they've used. You can also definitely check out the map score, which is the overall result of the. I did not do that because I just selected 5,000 images, which is not going to be accurate for my case. And then to find the top 10 classes, yeah, you can just do count values like how we do in pandas, and then sort them to get the report. So if you just do print report, it will give you the precision recall F1 score, and also the micro and macro average F1 score of everything. Yeah, this is the confusion matrix. And then, as I mentioned, this is the important part of this notebook, which is identifying hard samples so that you can curate your data set for a better model. Yeah, in this particular example, I used an image which has 7 correct detections, 3 false positives, and 0 missed detections, which is zero false negatives. And I think that's the image I show in this slideshow. But yeah, this is how you can manage and see which is better performing. You can even change the range and just select all the true positives so that you get an idea which image is better performing. Yeah, and then this is again repeating what I said, which is the taking a closer look at one image and one false negative and understanding why it is so. That is all.